What's going on? It's Toots Tutorial here. Today, we are going to solve some fundamental problems in strength of materials. It may not come out to your exam 100% exact, but at least we'll become familiar with it.
Yeah, man, it's just on and heavy roots.
So without further ado, here is the problem. Problem number 1. Determine the largest weight W which can be supported by the two wires shown. The stresses in wires AB and AC are not to exceed 100 MPa and 150 MPa respectively. The cross-sectional areas of the two wires are 400 mm squared for AB and 200 mm squared for wire AC. So in this problem, we are asked to find the largest weight that can be supported by these wires AB and AC, provided that the stresses or the limit before these wires will fail or will collapse is 100 MPa for AB, this AB 100 MPa, and then 150 for this AC. And we are also provided by each cross-sectional the cross-sectional areas of each. So to solve for this one, first thing we need to know is that since weight is a force, we just have to rearrange the formula for stress to find for the force P, which is also the W. So to find that, we just have to multiply the stress and the area. But what is the stress and area in this one? And what is also the P for this one, since this system is attached together and cannot directly say that the stress is 100 and the area is 400. We are given with 2. So to solve for this one, we will first find the forces in wires AB and AC in terms of the weight. So to do that, we have 3 options. Either we do it by summing the forces in the X and Y direction and then equate it to 0 to find the force AB or force AC, or we can tilt the axis parallel to one force here, example AC, parallel to that, in order to cancel out some unknowns for us or for the solution to become shorter. Or the third option is we have to draw a force triangle. So you can choose whichever you want here. So for my solution here, I will just use force triangle. So to do that, just remember the head to tip or tip to tail. So since wire AC is in tension, in order to support this weight W, we'll draw it like this. And then here's the wire. I know this is wire AC. This is wire AB. And this is the force W which we are looking for. Then we're given with the angles, which is for AC 45 degrees, 45 degrees, and then for AB, which is 30 degrees here, 30 degrees. But since if this is 30, this would also be 30 degrees here. There are parallel lines and then cut by this one. This angle and this angle are congruent. So you see, alright. And then if we make an imaginary line here and make it perpendicular to this one, we will have a triangle which enclosed by 45, 90, and 45 angle. And then for the other one below, this triangle is 30, 90, and 60 degrees. So our polygon will now look like this. This is W, this is AC, and this is AB. 45 plus 30 is 75. And here we have 45 degrees from here. And then 60 degrees below. So if we add 60, 75, and 45, that should be equal to 180 degrees since this is a triangle. So, to solve for this, we just have to remember the sine law. So, W over sine of the opposite angle, opposite of it, the angle opposite of it is 75 here, equal to AC over sine 60. AC sine 60, and then AB over sine 45. And then we just equate these two equations to solve for AC. We will get W sine 60 over sine 75. And then for AB, we will have sine 45, W sine 45 over sine 75. Now that we have the force in wires AB and AC in terms of the weight W, which we are looking for, the last step we need to do is just substitute it to the stress formula. So, stress area AB, and then for AC, just like that. Then if we substitute it, W sine 45 here, and then sine 75 is equal to AB is 100, and then its cross-sectional area is 400. 100 Newton over mm squared, that's MPa, times the area is 400 millimeter squared. And by inputting this to our calculator, we can get the value of W with respect to the wire AB, the force in wire AB and the stress in wire AB. Then for this one, let's move it here. This PAC would be W sine 60 over sine 75 times the stress, which is 150, and cross-sectional area, which is 200. 150 Newton over mm squared times 200. Yeah, it's 200 mm squared. Cancel. So we have value for W. So if we plug that into our calculator, 100 times 400 over sine 45 over sine 75, we will then have 54,641 newtons. Five, 4, 6, 4, 1 newtons. And then for AC, sine 60, 150 by 200, 150 by 200 over sine 60 over sine 75. We will have 33,460 newtons. You might be wondering, why do we have two W's here? What's the meaning of that? So we have two values for W here because we have two wires here which have two different stresses. And the W, if we substitute that to each of to these two equations, should not exceed the stresses like this 100 and 150. So if we try plugging in 33,460 to this W and came out to be less than this 100 MPa stress, therefore it will not exceed the 100 MPa. So if it will not exceed the 100 MPa stress, therefore it is safe. On the other hand, if we substitute this W to this equation and we got a result of greater than this 150 MPa stress, therefore this weight, if we put that here in our system, will no longer be safe, and eventually the wire AC will break due to that load. So if we try plugging in 54641 to this equation and divide it by the 200, 54641 times sine 60, sine 75, sine 60, sine 75, and then divide it by the cross-sectional area, we will get 244 MPa, which is greater than 150 MPa. Therefore, this force is not safe, and therefore the largest weight that can be supported by our system is 33,460 newtons. So this is now the answer. So that's it for this problem. And if you like this video, please subscribe, like, and share this video to your classmates.
Eagle double G.